Alright, so we're looking at dividing by 5. And no matter how we write it, with the division symbol as a fraction or long division style, the answer is 6. So let's look at a few other examples. 25 divided by 5 is 5. And 60 divided by 5 is 12. I'm going to make a little change here, and we're going to just add 0.0 to the end of each of these. Doesn't change the answer, but you'll see the connection here in a second. So let's start with 30. We're going to go ahead and double that. 30 times 2, 60. Now 25 times 2, that's 50. And 60 times 2 is 120. Now, some of you may have seen this, but we have 120 and 120, 50, 50, 60, and 60. So we already have a relationship happening here. The first step to our technique is to double what you're going to divide by 5, which we've done. And the next step is to simply adjust the decimal. So here we just shifted over 1, and that's our 6.0, as you can see there on the left. Shifted over 1, 5.0, and 12.0. Let's look at one that doesn't divide evenly. 18 divided by 5. First step is to double it, so 18 times 2 is 36. And then we've got to adjust the decimal. In this case, it will always be 1 to the left for dividing by 5. And here we have 3.6. So that 3.6 is our final answer of 18 divided by 5. Now the question is, why does this work? This is both helpful to know because it will allow you to remember the trick a little bit easier. So here's 18 divided by 5 as a fraction, which we will separate out as 18 over 1 times 1/5. Because dividing by 5 is the same as multiplying by 1/5. But 1/5 can be rewritten as 2/10. Exactly the same fraction, just a different form. And then we can multiply, and we can see that on the top. We'll get 18 times 2. That's the double of our technique. Divided by 10. Well, in our decimal system, dividing by 10 is easily done by adjusting the decimal. So we have 36 over 10, or as we said last time, 3.6. So let's look at another example. This one in a bigger font and with a decimal. So 24.6 divided by 5. First step is to double it. 2, 4, 6 doubled is 4, 9, 2. And now you may have noticed I'm ignoring the decimal point for now. We can just forget that. We'll add it in here in a second. The best way to do that is with some estimation. So it's about 25. And I know that 25 divided by 5 is 5. So I know my final answer should be around 5. Some of you might be able to spot this already, but 4.92 is our answer. We have one decimal here, which would move over, but the second one comes from our technique of dividing by 5. Remember, the adjusting of the decimal is simply moving one decimal place to the left. Let's look at another example, this one with a little bit bigger number. So we have 384 divided by 50. Now 50 is a little weird, it's different, it's not 5, but we're going to start with an estimation. I know the answer, after I reduce my zeros, is around 8. So we'll double that top number, and that's going to be 768. And now, for the top, we'd have to move a decimal, and for the bottom, that 0 divided by an extra 0, we'll have to move a decimal. So that's 2 decimals, which does put our answer right around 8. In general, you can pretty much ignore the decimals and use some estimation skills to get a final answer. So here's one with both decimals above and some extra zeros below. So we double the top number, and we do a little estimation. 250 over 500 reduces to about 1/2. So we know the answer is going to be about 0.5. So we just can throw in that decimal right at the front, 0.48272. So that's your technique. Double the number you're dividing by 5 and adjust the decimal. See you next time.